Hey guys, my name is Olasehinde, and in this tutorial we are going to be covering CHM 101.
Hello guys, welcome to another tutorial.
pH.
CHM 101, and this time around we're explaining the concept of
let's get
started.
Change because we didn't multiply through.
Firstly, what is pH?
pH is just the negative log reading
sure that this sign still isn't changing
of hydrogen ion concentration
negative number
of an acid of any substance.
Then this one becomes
so that's basically
less than x.
The definition of pH. That's what pH means. The hydrogen ion negative log of hydrogen ion concentration. That means pH in formula form negative log hydrogen ion concentration.
I'm going to treat
that's basically it. So if you know the concentration of hydrogen ion of a substance,
so that
you can just find the pH of it so easily.
I'm going to treat a quadratic inequality so we understand.
It is important before we go to any calculation. It is important to note that the concentration, because basically pH scale basically is gotten from that of water at 25 degrees Celsius. That's room temperature. The concentration of water is actually balanced. That's the amount of hydrogen ion and hydroxyl ion in it is actually the same, which is 1 times 10 raised to the power minus 7 molarity, and the same way it is the same. So we can say the concentration of water H2O is 1 times 10 raised to the power minus 14 at room temperature. So we can just state this. It's just very important to note this because it's going to be useful later on in this tutorial. Okay, now let's try an example. Let's try an example. Find the pH of 0.01 molarity HCl. Find the pH of 0.01 molarity HCl.
This is a question on quadratic.
Okay, so just like we said,
we're trying to solve this.
The hydrogen ion concentration, just say pH equals. So now let's try to break negative log.
Let's see if we can
concentration 0.01.
Middle number here is
0.1,
and this
is then
find two numbers, you multiply
we can just simplify and -2 using the laws of log reading. This power comes down. I think that one shouldn't be new to us.
So
then 2
x squared.
That means the answer here is 2. Okay, you are good, you are correct.
Less than 0. So since
it's very
minus 2 and plus 1,
this concentration depends on the basicity of the acid, because this concentration is the concentration of HCl. 0.01 is the concentration of HCl, not the concentration of H. So that means it's possible the concentration of hydrogen ion is different from the concentration of the compound itself. I believe I'm communicating something. Okay, so basicity, I mentioned basicity is actually the amount of hydrogen ion concentration,
now from
in
this point
the substance. So the basicity of HCl is 1 actually, because hydrogen ion is also 1 here. When you have some stuff like H2SO4, H3PO4 and the likes,
isn't it? And that's the answer. But it doesn't stop just like
the basicity of this is 2, because hydrogen ion concentration is in 2. We have 2 hydrogen ion concentrations here. 2 hydrogen ion, 2 molecules of hydrogen ion. Sorry, let's speak in chemistry terms. So
brain draining.
the basicity of this one is 3, because you have 3 moles of hydrogen ion in it. So it actually depends on the basicity. So the best way to approach a pH question is firstly check for the basicity of the acid. For this one, we are in luck because it is just 1, so it doesn't still change anything. But if the question goes like find the pH of 0.01 molarity H2SO4, if you try it this way, then you are very, very wrong. Because you have firstly need to dissociate this H2SO4. By the time you dissociate it, it is 2H plus SO4 2 minus, isn't it? Okay, I know we're already going into all those. Some people are always very, very scared of dissociation and all these things. They're actually not difficult. So since we already know that this is 2, and we already know that the molarity of H2SO4 itself is 0.01. So in order for us to get the molarity of H, we all have to multiply it by 2, since stoichiometry, stoichiometry. So okay, let's do it. I wanted to rush this before. Let's do it in the stoichiometry way. The multiplication of these so that you at least we can use that to cover stoichiometry also here. So we can see that based on the standard, we can see based on the standard downward like that. So 1 mole now want to test it of H2SO4 which range of produces 2 moles minus of hydrogen ion concentration, isn't it? Based on the standard from what we see here. So now firstly we've picked this one. 0.01 mole of H2SO4 should give what? Then you can then say you want to cross multiply and say x equals to 2 times 0.01 mole and 0.02 mole of H plus. So having taken down that out, you can now find the pH. You can now say the pH of this is negative log 0.02. Multiply these two, then you break it down, you solve, you do everything you want to do to get your answer. So that's, I just quickly took that one out because you might get questions like this in your exam, and doing it this way is actually wrong. So it depends on the basicity of the acid. So that's for pH. Now let's go into pOH. Again, minus 5. If you multiply, it's 2 now plus. pOH is just like we've said about pH. pOH is the negative logarithm of the hydrogen hydroxyl ion concentration. Hydroxyl ion concentration is just the negative logarithm of it. So pOH equals to negative log 0 to 1 fits here, since we said it's less than ion concentration. So this one actually measures the base side of I hope you understand why I changed this one to x is greater than minus 1. So it's just like, say, basically it's still the same way. And for example, you might have what is the pOH of sodium hydroxide with concentration 0.01 molarity is less than x. So it means if you have questions, because you know that NaOH is base, we all would know that it's base. So we are sure that if we do, so pOH equals to negative log values that fit there 0.01, and we get the answer to be 2, then we are correct. Now let's put 0 and 1 inside this equation. Let's try 0 first. The same method still. What works for pH still works for pOH. So let's not waste much time on it. You just need to know, okay, if this is an acid, if this is a base. -2. Now, but there are times when questions are always twisted. For example, you might be told to find the pH. So 1 plus 1 minus 2. This is 2. This pH of 0.01 molarity. NaOH. Now let's go to this one, greater than 2. The question is twisted here, isn't it? Usually pH is supposed to measure the acid. We are talking of measure the concentration of an acid, isn't it? But this time around, this is a base, not an acid. Plus 1, then how do you do it? 2. This is 4. You have to be very careful when you have questions like this. If you see questions like this, actually a tricky question. You cannot just jump into doing negative log 0.01, and since you know that the hydroxyl ion concentration is just 1, it is not 2, so you can just jump into doing the no. You can just jump into it. This one in the middle. it is only this one. So the answer
Because
is
if you say you are doing
-1
pH, you are
less than
calculating
x less than
the
2.
acid side of this.
Now we have finally solved
You are,
it.
you are
So imagine
calculating
you have something
you are
like this
calculating the
in
base
exam
side of it, because this one originally is base.
So
If you
this
just say
is
pH
actually
equals to
a
0.
pure waste of
Negative
time.
log
It's a pure waste of time.
0.01, you are
So how do we
calculating
do
the
this
base, not the acid.
in exam?
So
Because it's a
since you know it is a
shortcut,
base,
and this is the part you have been waiting for.
since you know it's
So
base,
if
and
you have waited this far, congratulations.
what you
I'm
first
about
do
to
is
show you
calculate the
how to
pOH.
get
Yes,
the answers
because
to
that's what will
inequalities
fit this with this
very fast.
concentration, pOH.
Sometimes you might not even
Now
solve anything.
pOH equals
Sometimes you might require you to solve.
negative log
Let's take
0.01. I'm comfortable doing 0.01 because I only have the hydroxyl ion concentration here is just 1, it's not 2. So I'm comfortable doing, I'm not multiplying anything, I'm still correct. Okay, now pOH then is, by the time you solve this, you get 2. pOH is 2. Okay, now, but the question is find pH, not pOH. So we need to find a way of converting pOH into pH. Now that brings us back to what we mentioned about water. The concentration of water is 1 times 10 raised to the power of minus 14, which is, if you find the power of water, you get 14. Now remember that we said at room temperature, hydrogen ion concentration of water is the same as hydroxyl ion concentration, and by the time you multiply it together, it gives you that of water. So if we find the power of this, it means power of this times power of this, power of this. So power of water goes to power of, remember that if you find power is log is log function. Okay. So if you find log m times n becomes log m plus log n, isn't it? So that means power of hydrogen ion plus power of hydroxyl ion. That's what it will result into in the end. So since this is water, we can say 14 equals to power of hydrogen ion plus power of hydroxyl ion. This is actually the formula that you need to know. This formula is what you need to know. So this formula basically will help you to convert from pH to pOH. So since what we want to get here originally is
guys,
pH, not
now
pOH, so we can then say 14 equals to pH plus pOH. And can then say pH equals to 14 minus pOH. Then pH equals to 14 minus 2, and that's 12. So pH is 12, which is base, greater than 7, it is a base. So that's basically how to solve questions like this. Any question I feel that is very tricky, start solving these are the first instance. Question is pH answer 0.01 any of the option that fulfills this condition of being less. Just like I said, if we can find a way of converting this one, we know that the concentration here is base, not the acid. Since this is in range, because this quickly pen it down. Is a base. Remember that this one is, if we can find a way of converting x is greater than minus 5 and x is less than minus 1. The acid side of it shouldn't be new to you guys again. We're finding pH, x is greater than minus 5, that's minus 4, getting the minus 3, minus 2. Converting this one originally, we are still using that same formula, but this time around we are not using this. These are the values. Now let's try and see. We are not using it in its power form. Fix them into this place. We are using it in concentration form. So since we already know that the water is 1 times 10 raised to the power minus 14 minus 1. Now what's the absolute value of minus 1? You can bring in the acid here. And 1 is acid, the acid and base. But you cannot just, because you have seen balanced on the range of 14. Because you've seen balanced on the range of 14, so with the idea, you can get any side, whether it's the acid side or base side of any substance, you can get it. Okay, so now the acid here is 0.01. Plus 3 less than 2. Now let's put minus 3. Sorry, minus 3, that's minus 3 plus 3. The acid side is what we are trying to find, since it is a base. This one still fulfills the condition. The base side is 0.01. That one will fulfill the condition. Now we can then say H plus, since this is concentration, this is multiplication, that we can divide it, say this. So it fulfills the divided by 0.01. Fulfills the condition. That means we can bring in the idea of indices.
This is 10 raised to the power minus 2, isn't it?
let's just try the remaining.
10 minus
B.
14 minus 2.
Basically,
10 minus 14
if
plus 2.
we take out the time
10
of me talking and
minus
trying to explain
12.
the method, basically you've solved this
10
in
minus 12.
space of seconds.
So we've already gotten so the acidic part
let's try and
see the substance. Now we can then say
if
pH
equals
equals
some of them
to
are also
negative
the
log
condition
concentration of the acid in it
so x is greater than 5.
minus
Let's
log
put 5 here.
0
greater than 5,
10
that's
raised to
like
the power
6,
minus
7
12.
and the like. So let's put
This is
6.
10. So since
6
remember
plus
law of
3 is
logarithm,
there's
this
no,
power
it's
comes
not
down
even anywhere
minus
close to being less
minus
than
12.
So this is not the
Then
answer.
this one turns to 1.
Now
So
this one,
is
the
2.
its
So
range
you
of
can see that
values
it's
it goes
2, which
from
is
1
exactly
to 0
the same
to
as
0
what we
to
originally
0
got
1.
here too, which
So
is
let's
what?
put 1 here. 1 plus 3.
12. So
That's
we
4.
can
Not
solve
even
it using
anywhere
those two
near.
approaches, and basically that's pH. That's how to
This
deal
one
with
is the
pH.
range. It ranges from
Probably
minus 2
in
to
the future
10
tutorials we are going to
plus
cover
2.
more.
So that's minus 1.
Thank you. I remain
0
Olasehinde.
1.
Bye.